So Chapter 4, Section 5 deals with triangle congruence, SSS and SAS, which I'll go over what both of those mean in the next couple of slides. So in 4.4, we proved that triangles are congruent by showing that all 6 pairs of corresponding parts are congruent. We had 3 angles and 3 sides that were congruent, and that meant that the triangles were congruent. Now we're going to see that we don't need all 6 parts to show that 2 triangles are congruent. The property of triangle rigidity gives you a shortcut for proving that 2 triangles are congruent. Triangle rigidity states that if the side lengths are given, the triangle can only have one shape. So we're going to come to our first postulate, side, 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 which is SSS. That's what the SSS stands for, side, side, side. If 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. So here we have 2 triangles. We have a side with 4, a side with 4, so that we have 1 congruent pair, a side with 6, and a side with 6, so that's 2 congruent pairs, and a side with 7, and a side with 7, and that's 3 congruent pairs. So if there are 3 congruent pairs of sides, then the 2 triangles are congruent. So remember, when naming the triangle, when saying that their 2 triangles are congruent, we need to keep the sides in the same consecutive order. So if we start with A, so the side that's 4, and go to the side that's 6, and then end with the side that's 7. So if we go A, B, C, in the next one we have to go F, D, E. So we have to go in the same order when naming that the 2 triangles are congruent. So just keep in mind that it needs to be the same order, or the same consecutive order when naming them. So adjacent triangles share a side. So you can apply the reflexive property to get a pair of congruent parts. So if we had, let's call this point A and this point B, and we're talking about this segment AB. AB is part of this triangle to the left, our first triangle. It's also part of the triangle to the right, the second triangle. It's the same side, so we know that this side AB is going to be congruent to the same side AB because of the reflexive property. And now we're going to look at some examples that involve the reflexive property when proving side, side, side. So use side, side, side to explain why triangle ABC is congruent to triangle DBC. So remember, in SSS, we need to prove that we have 3 pairs of congruent sides. So we're going to have 1, 2, 3 sides that are going to be congruent. So it's given already. We see that because we have this tick mark here, that AB is congruent to BD. So we can write that as our first side, our first pair of sides that are congruent. So AB is congruent to BD. And now we have 2 sides that have 2 tick marks, so we know that AC is going to be congruent to CD because both of those have 2 tick marks. So our second side that's given to us that's congruent are AC and CD. And our third side of the triangle is going to be the side in the middle. Since that's the same line, we know that BC is going to be congruent to BC. And we know that because of the reflexive property. So BC is congruent to BC, that third side that we needed, because of the reflexive property. So therefore, triangle ABC is congruent to triangle DBC because of by side, side, side. These two triangles are congruent. So triangle ABC is congruent to triangle DBC by the side, side, side postulate. Now we have another example. So use side, side, side to explain why triangle ABC is congruent to triangle CDA. So again, when we're using side, 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 we need to have 3 pairs of sides that are congruent. So we have 1 side, 2 sides, and 3 sides. So we're going to have 3 pairs of sides that are congruent. So first it's given, let's look where we have 1 tick mark, that AB is congruent to DC. That's given to us. So segment AB is congruent to segment DC. Next we can look and see where we have 2 tick marks. We have 2 tick marks at AD and CB. So we know that AD is congruent to BC, because that was given to us as well. Next, for our third side, we have the same side in the middle here, AC. So we know that AC is going to be congruent to AC because of the reflexive property. So now we have 3 pairs of sides that are congruent. So therefore, triangle ABC is congruent to triangle CDA by the side, side, side postulate. So triangle ABC is congruent to triangle CDA by side, side, side. So we have 1 side, 2 sides, 3 pairs of sides. That shows us that these 2 triangles are congruent to each other. So now we're going to move on from side, side, side and look at our next one, which is SAS, so side, angle, side. But before that, we need to talk about included angles. So an included angle is an angle that is formed by 2 adjacent sides of a polygon. So here we have side AB, this side, and side BC, this one, and the included angle, which is B, is the angle that is right in between them. So we have 2 sides, and right in between them is the included angle. So now we're going to look at the side, angle, side postulate. So if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the triangles are congruent. So here we have 1 side that's congruent to 1 side, and another side that's congruent to another side, and the angle that's in between of both of those, so the angle in between the first triangle and the angle in between the second triangle, are also congruent. So therefore, we can conclude that these 2 triangles are congruent. So triangle ABC is congruent to triangle EFG. So remember, when we are naming this part, that these 2 triangles are congruent, we have to keep it in the same order. So if we're going ABC, so from A to B, then to C, we need to keep it in the same direction. So we have to go E to F to D, so EFD. So now we're going to use side, angle, side to explain why triangle XYZ is congruent to triangle VWZ. So remember, when we're using side, angle, side, we need 3 things. We need 1 pair of sides that's congruent, 1 angle that's congruent, so that's our second thing, and then the third thing we need is another side that's congruent. So side, angle, side. So in this example, it's given to us that XZ is congruent to ZV. So that's our first side that we know is congruent. So XZ is congruent to ZV. It was also given to us, if we look at the two tick marks here, that YZ is congruent to WZ. So our second side here we have YZ is congruent to segment WZ. And now we need our angle. We need a pair of angles that are congruent in order to prove that these two triangles are congruent. So if we look at the angle that's in between, because when using side, angle, side, we need the angle that's in between the sides to be congruent. So if we look at the angle that's in between the two sides, we need these two angles to be congruent. What do we know about these two angles? We know that these two angles are vertical angles. So angle XZY is congruent to angle VZW because they are vertical angles. So now we know that triangle XYZ is congruent to triangle VWZ by side, angle, side. Now we're going to look at another example. So use side, angle, side to explain why triangle ABC is congruent to triangle DBC. So again, when we're using side, angle, side, we need three things. We need a side, an angle, and a side. 1, 2, 3. So it's given to us right off the bat. We know because of these tick marks that side AB is congruent to side BD. So we can write for our first pair of sides that AB is congruent to BD. Because of these arc marks here, we know that these two angles are congruent. So angle ABC is congruent to angle CBD, and that was given to us as well. And lastly, it's not given, but because these two lines are the same exact line, we know that line BC is congruent to line BC because of the reflexive property of congruence. So because of the reflexive property. So now we have our three things. We have a side, so we have this side, this side, this side, and the angle that is in between those sides. This angle and this angle are congruent. So now we know that triangle ABC is congruent to triangle DBC by the side, angle, side postulate. Now we have an example with some numbers. So we're going to show that the triangles are congruent for the given value of the variables. So triangle MNO is congruent to triangle PQR when x is equal to 5. So remember, when these numbers are listed, they're listed in a specific order so that MNO is consecutively congruent to PQR. So if we start with side MN, we know that this side is going to be congruent. So we're looking at the first two letters of the next one. So MN is congruent to PQ. So we have to prove that MN is congruent to PQ. So let's look at PQ, which we know is x plus 2. So when we plug 5 into x, we get 5 plus 2, which is equal to 7. So is 7 congruent to MN? Yep, that one's 7. So we know that MN is congruent to PQ. That's our first side. Next, let's look at our next side. So we can look at NO. So the second two letters here, so it's going to be congruent to the second two letters in the second triangle, so QR. So let's look at side QR. QR is equal to x, so when we plug 5 into x, we get 5, which is the same thing as NO, 5, so that's perfect. NO is congruent to QR. So that's our second side. And lastly, we can look at MO. So we're going to look at M and O, so the first and third letters, so we know that that's going to be congruent to P and R. So let's find out if they're congruent. So we have PR is equal to 3x minus 9. So when we plug 5 in for x, we get 3 times 5 minus 9, which is 15 minus 9, which is equal to 6. So is 6 equal to MO, this side? Yes, perfect, 6. So our third pair of sides are going to be congruent. So MO is congruent to PR. So now we have 3 pairs of sides that are congruent. So therefore these two triangles are congruent by side, side, side. Now we have 2 more examples that are proofs. So in example 6, it's given that BC is parallel to AD and segment BC is congruent to AD. And we're trying to prove that triangle ABD is congruent to triangle CBD. So now let's look at the proof. We have segment BC is parallel to AD. We've seen this before right here in our given, so our reason for number 1 is given. So our statement number 2 says that angle CBD is congruent to angle ABD. This is a typo, and it's supposed to read that angle CBD is congruent to angle ADB. So we're looking at CBD, this angle, and ADB, this angle. So we need to know why these two angles are congruent. If we look at this line here and this line here, we know that they are parallel. We can cut these two lines by the transversal BD, and therefore we know that these two angles, CBD and ADB, would then be alternate interior angles, and we know that alternate interior angles are congruent. So this is our reason for why CBD and ADB are congruent, because of alternate interior angles theorem. So this says alternate interior angles theorem. I just abbreviated a little bit. So next we see for statement number 3 that segment BC is congruent to AD. We already saw that again here in our given, so we know that our reason for number 3 is given. For step number 4, it says that segment BD is congruent to segment BD. That's the same thing. So we know that this is true because of the reflexive property. And it has a congruent sign, so the reflexive property of congruence. And then step 5 is what we were trying to prove, that triangle ABD is congruent to triangle CBD. So here we have one side that's congruent to another side, and an angle that is congruent to another angle, and another side that's congruent to the other side. So we have a side, an angle, and a side. So we know that these two triangles are congruent because of the side, angle, side postulate. Now we have our last example. So it's given that QP bisects angle RQS and that segment QR is congruent to segment QS. And we need to prove that these two triangles are congruent. So statement number 1, QR is congruent to QS. We already saw that here in the given, so we know our reason for this is given. QP bisects angle RQS. We know we already saw that in the given too, so our reason for number 2 is also given. So let's look at our triangle. What information is this giving us by saying that QP bisects RQS? So when QP, this line down the middle, bisects RQS, remember it cuts it in half. So now we know that this angle RQP is congruent to this angle, SQP. Well, let's look at step 3. Angle RQP is congruent to angle SQP. We just said that we know that those two are congruent because of the fact that that line bisects. So because of the definition of a bisector, that is how we know that those two angles are congruent. So that's our reason for number 3. Statement 4 says that QP is congruent to QP. That's talking about the same statement, so we know that QP is congruent to QP. And that is because of the reflexive property of congruence, because remember, there's a congruent sign. And lastly, we come to what we're trying to prove, that triangle RQP is congruent to triangle SQP. Well, if we look at this triangle, we have a pair of congruent sides, another pair of congruent sides, and in between those two sides that are congruent, those two pairs of sides that are congruent, we have two congruent angles. So we have a side, an angle, and a side. A side, an angle, and a side. So we know that these two triangles are congruent because of the side, angle, side postulate. So that's everything you need to know for section 4.5. So if you guys have time left at the end of class, you can go ahead and start working on your homework.